All right. Hello, everyone. Welcome back to Comp 2150, Object Orientation. I can't believe that it's colder today than it was on Tuesday. I can't believe that. Okay, end of conversation. Let's stop talking about the weather. I want to keep working on this. So there's a few new things that I want to do with what we've been working on. Last class, we started to use strings in our program. And the thing that I really want to do today is I actually want to do comparisons on strings. I actually want to be able to make comparisons between a couple of strings. And we're going to approach that by making a change to the way that we are adding Pokemon to our trainer. Wow, this is terrible. Try auto, see if that fixes the colors. I also want to talk about a few things related to C++ and how it differs from Java and how it's similar to Java in a couple of ways. So I want us to see how to use class variables in C++ today. Last time we left this with like a hard-coded number 6, which is not great. So I'd like us to fix that. I also want us to spend some time building up class hierarchies in C++. So how do we actually do this? What's different between C++ and Java? And what are we going to actually build? How are we going to design this? Before I get into any code, I want to tell you, remind you that there's a term test. So there's a term test 1 week from today. It's going to be in class. It's in class. The term tests for us, we have a 75-minute slot, but the other section of this course does not have a 75-minute slot. They have a 50-minute slot. So that kind of means that for fairness sake, our test will also be only 50 minutes. So when I'm giving the test out, I'm going to be setting a 50-minute timer and not a 75-minute timer. I haven't done this before. I haven't done this before where I have a test that's smaller than the time for the class that's allocated. And so I have a couple of options. One is just to start the test immediately when the class starts and then just end early. The other option is to have some small review before the class starts officially and then let the test run. But honestly, my plan is to maybe do a little bit of review on Tuesday next week before the class even happens. So I'm kind of thinking that I'm going to start the test pretty much when our class period starts, and then we'll just end class early on Tuesday, and then, or I'm sorry, on Thursday, and then you're welcome to stick around and ask questions if you want. But otherwise, go home and enjoy the weather that's a little bit warmer. The format of the exam for the test is going to be, there will be approximately 5 multiple choice questions, there will be approximately 5 short answer questions, and there will be 1 or 2 programming questions. So again, this is meant to be sized to be a 50-minute test, not a 75-minute test. The content that's going to be on this test is going to be up to and including today. So wherever we end today, this is where the material for that test stops, is at the end of today. So even if we don't finish what I want to finish today, I don't know why I'd test you on something that I haven't told you about. That would be terrible. I don't want to do that. So whatever we finish today is where we will stop the content for our course. Are there any questions about the test? Give you a chance on Tuesday, when we do a small review, but yeah. So we haven't set the test yet, but I would expect that if we're going to have 2 programming questions, you'd have 1 of each. That would be my expectation. We're good. We're okay. Good, good. Okay. All right. Let's start talking about how I'm a bad person. There. That's me. There are 2 things that I've messed up. There are 2 things that I messed up. And I don't want this to be like my failures as in like, this is my personal failure in life and I just can't move on from this. It's more of a, let's learn from my mistakes sort of thing. There's 2 things. Basically, I want to document this so that when you see some of these things yourself, you have a record of what we're looking at. There are 2 places where I've kind of messed up with stuff this term so far. It's only been 4 weeks, so there's lots of time left. Number 1 was I forgot to include something, and we kind of fixed that last time. And the problem that we got left with last class was that I forgot to update my make file. About 30 seconds after this class was over, I was talking to people after the class is over, and I'm just like, farts, yeah. That's what the problem was. So what I want to show you is the problem. So what are we seeing coming out of the compiler when these problems are in our code, and what the fixes are, and then some general advice before we get into actually talking about building up the code example that we've got. So this is the first thing that I made a mistake about, which was that I forgot to include some standard libraries when I am trying to use strings in my program. This was the error message, or at least a similar error message to what I was getting out of Clang++ when it was trying to compile my code. The thing to remember about this is that this specific case, strings are not part of the language like they are in Java, so we have to actually include something to get access to strings. But if you see this undeclared identifier, std, or other stuff, so something similar to the structure of that error, a common problem here might be that you've forgotten to include something that you should be including. In this case, the solution here was to add that include. This might be solved transitively, so if you include IOStream, remember that also transitively includes string. But that was the solution to the problem in that case. And then last class, the error message that I was running into, and I believe that it was at about 3:05 p.m. where you could start to see me like sweating and like freaking out a little bit. Yeah, oh no, what's going on? Why isn't this working? This was the error message that we were looking at. This is the error message that we were looking at. And if I had taken the time to actually read the error message that was being printed out to my screen, I might have been able to figure this out in class. But very honestly, I was just like panicking, a little bit of panicking. First of all, I believe that this emoji accurately describes the kinds of error messages that you see from the compiler and linker with C++. The error messages that you saw coming out of C were at least shorter. They were at least shorter when there were problems with the code that you were writing. Whether they were helpful to you or not, I don't know, but C++ compile and link errors are kind of a mess. The keywords in this error message, there's actually 2 sets of keywords. The keywords that I see right here are undefined reference to, and then it's a long mess. I fully admit this is a long mess, but it's an undefined reference to. The other thing that's a keyword here is that it's actually not the compiler that is issuing this error message. So user bin LD, this is the loader or the linker. This is the part of the compile process that's basically taking all of these .o files and trying to stitch them all together into a single program. If the compiler gets past compiling your code, that means that it was syntactically valid. there was a declaration of a method, or a constructor in this case, that matches this. There was a declaration of a constructor that matched this. But we got to the linker, and the linker tried to find the implementation of that, and then it couldn't find it. That was what the issue was here. It wasn't able to find that. The solution here was and is that I needed to add Pokemon or trainer.o and Pokemon.o as a dependency on main in my make file. So I want Clang++ and make to actually have all three of those different .o files being used when it's trying to compile my main.cpp. So if you look at this Clang++ line, it's compiling main.cpp, trainer.o, and then that's it. And it doesn't have Pokemon.o there. So it doesn't have an implementation of that constructor to link into the main program that's trying to be compiled. Some general tips. That first one that I gave you last time was just scroll up, like way up, especially if it's a compile error, and try to find the first instance of the message. The second one, and this is more for me than you, is read the error message. Just like stop, calm, breathe, and read the error message that's being printed out to you. And the other one that I want to share with you that honestly I was kind of blown away by is ask ChatGPT for help. And I'm not totally joking about this. I feel like this is a legit way to go about asking questions. So let me edit my make file here. The mistake is still there. This is kind of where we left things off. The mistake is still here. I'm going to try to compile this. Make this a little bit bigger. I'm going to copy this whole thing. And I'm going to go to ChatGPT, and I'm going to say, and assuming that it doesn't say like, sorry, there are too many people trying to use the system right now, because that's been a common response lately. Assuming that I can submit it. Oh, come on. This is really going to not be a great example if I can't actually, yeah, okay. Oh. Yeah, refreshing is definitely going to solve the problem. Refreshing is helping them scale their systems. Well, I'm going to wait. I'm not right now. I'm not going to wait for this to finish, like getting more scale to their servers or whatever. But I don't know. I'll show you this on Tuesday. Not only did it tell me what the problem was, but it told me how to fix it. And I really wish I could show you this because it's kind of mind-blowing. It took this mess here of, this is the long name for a string in the C++ library that you're using, and it crushed it down to std string in the output that it was producing. ChatGPT is a good debugger. It's a good compiler debugger. It's a great compiler debugger. 5 stars, would recommend. It's not helping. It's not helping. Okay. Let's keep building our something more complex in C++. As before, so I didn't say this last time, but as before, I've got kind of a lot of slides here that go down. And they're for your reference. I might not refer to all of these slides in class because I might just be putting it into the program that we're writing. But you can use these slides as a reference tool if you are looking for something and you don't want to spend the time to watch the entire video because you're sitting here right now. So if you are looking for a bit of a reference, this is a good place to find that. So I want to update some of the goals that we have for what we are trying to build right now. I want to use strings in a C++ program. We've declared them, we've initialized them, we've printed them, but we haven't compared them yet, and I do actually want to compare them. The way that I want to compare them is I want to add a rule to my system that I can't have two Pokemon that have the same nickname. So I'm going to do comparisons on strings there, and I'm going to reject Pokemon. So I'm not going to allow you to add a new Pokemon to a trainer if it has the same nickname as another one. We used arrays last class, and I want to update this only in the way to use class variables in C++. I don't want to have a hard-coded 6 in there. I want to have something that is a named variable. For the record, you can use number sign define in C++ in the same way that you could in C. You can use that approach, but I want to show you class variables in C++ and how to use them. I want to create a class hierarchy with inheritance and polymorphism. And we're going to spend some time thinking about which class we should actually extend in the structure that we've created so far. Related to that, I want to be able to create abstract classes in C++. So one of the things that we're going to do is start to build up this hierarchy. It's going to be fairly shallow. It's not going to be a deep hierarchy. It's not going to have many levels of classes beneath it. But we're going to find that there is a need for abstract classes in what we're building. I want to spend some time talking about stack versus heap allocated objects. These are words that you should have seen before. These are words you should have seen before. I'm not sure of the full context that you've seen these words in. Did you talk about stack allocated structs in Comp 2160? Yes, no. Some yes, some no. Okay, great. We will try to make a point of just talking about it in general. We'll talk about it in general so that we're all kind of on the same page here. If we have time, I'd like to show you debugging with LLDB for C++ programs. This is something that is a tool that is important for you to know how to use when you are doing C++ programming, especially when you are doing C++ programming where aviary is the target, a remote system that you can't sit in front of. Let me restate that. A remote system that you probably don't want to come to campus just to sit in front of. Yes, you can go to the Linux lab. How many of you have been to the Linux lab? Anybody? A couple of you? Do you know where it is? Yeah, the Linux lab, the bird machines. Do you know where it is physically? Do you know where my office is? Nobody comes to my office. So, okay, you walk out this door right here, walk out this door, and you turn right. And then you go past the turn off towards, I forget what that building is called. Allen? Chemistry, and then the geology building. Don't go that way. Don't go toward the geology building. Turn left toward University Center. And then either like take the shortcut and go out the doors of University Center and then immediately beeline to the entrance to the underground tunnel and then take the stairs up to the 4th floor. And as you're leaving the stairs, if you look out that door, there's a window there. And if you look just to the right, that's my door. You can see my office. It's right there. It's a little cold, but it's a good office to come to sometimes. If you want to go to the Linux lab, turn left, and it's just around the corner. It's right there. There's a combo on the door. You should be able to run a command on aviary called combos, and that will tell you what the combination to this door is. If you can't run combos for some reason, you can email me and I'll tell you what the combination for the door is. You are a 2000 level CS student, you should have access to that room. So just let me know. Regardless, you probably don't want to go there just to debug your code. It's going to be a lot nicer if you can debug your code in the command line. Did you do LLDB with C? Did you do that with C? Okay, good. So this is not going to be a huge thing. It's just going to be like, let's make sure we can do it. That's it. Good, good. I want to build us a list, and I want us to build a constructor. I want to build a node class, and I want to use something called a destructor to be able to clean up the class after we're finished. All right, so let's get into this. So I'm gonna fix my makefile. We're still in that same state. I want to fix my makefile, so I'm gonna add Pokemon here, and I want to make it, and it works this time. it works this time, and I'm going to go back to main and just kind of remind us of where we were here. We've called the null array constructor for one trainer. We've called the other constructor for another trainer that takes a string as its name. We've used cin and cout. We are asking for the type, the nickname, and the maximum number of hit points for a Pokemon, and we are constructing that Pokemon. We are constructing another Pokemon using some hard-coded values. We're using those PokePrinter classes to print out these things. So we're extracting the print functionality from the Pokemon class and giving that responsibility to another class. We're printing out their values. Bulbasaur attacks Pikachu, and then we print out the value that, that Pikachu has just to make sure that its HP was reduced by 5. That was what our attack was, is to reduce the HP, the current HP that our Pokemon has by 5. And then finally, we are deleting our constructed resources. So we use that new keyword, the constructor, to create instances of these trainer classes, and we're deleting them. We should also delete Bulbasaur and delete Pikachu, just to make sure that, that everything's done. We should also delete our printer and bulb print. I'm going to make sure that I've typed the right case here. I have. Clean up our resources, and then return 0. For the record, this return 0 is optional. You don't actually have to have that at the bottom of your main function in C++. You can omit that, and it's still going to compile correctly. OK, so we're still good. The very first thing that I want to do is I want to make a change to the way that trainers work. In my game here, I've got a trainer, and I've got this list of Pokemon. Why is it so bad today? It's better if I just don't have the lights at all. All right, awesome. I have this list of Pokemon. But it's going to be really, really confusing if I have multiple Pokemon that have the same nickname. So my justification for this is that I don't want to allow multiple Pokemon to have the same nickname that's in the roster for a trainer. I'd like to make a couple of changes. The way that we're adding Pokemon to a trainer right now is with this method. So method signature here is function return type void. The class that we're implementing this method for is trainer. The name of the method is add Pokemon, and then the thing that we're passing to this is a pointer to a Pokemon. The goal that I want to have is I want to reject Pokemon with the same nickname as one that's already in my roster. I don't want to have 2 Pokemon in this list that have the exact same name as what I had before. When I do this, I want to change the signature of this method. I want to change the signature of this method so that I can tell my caller that I have rejected what they have passed to me. We're going to do this today in the C way. We're going to do this in the C way, where we're going to have a return value that says, true, yes, I added this to your roster of Pokemon, or false, I did not add this to your roster of Pokemon. I think a better way to approach this would be to use exceptions. So to throw an exception if you have a duplicate so that you can handle that in the caller. But for now, I just want to stick to something simple. I just want to keep it simple and kind of go with it that way. So I need to do 2 things. I have to open up trainer.h. Here, I'll put it to the side. I need to change the return type of my method in my interface. In C++, we have a bool. We've got bool. Great, excellent. It's an actual type. It's not just 1 or 0. It can be 1 or 0, but it's not just 1 or 0. It's an actual type that we can use for stuff. And we don't have to include anything because it's actually part of the language. Great, good job, C++. Yeah. So so the question is, can C++ still use integer values as a condition? So basically, 0 is false, non-zero is true. Yes, it can still do that. Most of the time, though, and idiomatically, you should be using bool instead of doing integer values to represent those things. Yeah. So I've changed it here in my method interface. I'm going to save it, and I'm going to change it here. So I'm making modifications for what it's worth to the sample that's posted up on the course webpage. So if you want to follow along, you're more than welcome to. Because I've made this change, I need to return something. So I'm going to return false by default. It's lowercase f false. It's great. It's so much better than what C had for us. To do this, I'm going to have to iterate over the Pokemon that I have right now, and I'm going to have to check all of their nicknames to see if it's the same as the one that I have to add. So I'm going to write a for loop to do that. I'm going to say for int I is equal to 0, I is less than, and we've got this nice property here called cur Pokemon, so I'm going to use that. I++. And the way that I'm going to do this is I'm going to use a Boolean value. I'm going to say dupe, call it a duplicate, dupe. By default, there aren't any duplicates. And then I'm going to say duplicate or equals. To add is the Pokemon type. And to Pokemon, we previously added this nice get nickname method. It returns type string. It's an accessor for that type. So I'm going to say to add get nickname. Okay. And then I'm going to do what you've been told not to do for so long, for so long. Java, stop doing that. Don't use double equal signs to compare strings to each other. I'm going to use double equal signs to compare strings to each other in C++. I'm going to say this, and then the trainer class has this property Pokemon. So I'm going to say this Pokemon at I. This is an array of pointers to Pokemon, so I still keep using that arrow operator. I'm not using dots here in any place because this is a pointer, and the array that I have is also pointers. Semicolon. I'm going to put this on 2 lines just so it's a little bit easier to see here. Okay, so are we okay with this loop structure? We've seen or equals before. Have we seen that? We're good with that? No, you haven't seen or equals? Okay. Or equals is the same as and then that expression. So or like that. So it's just the same as that expression. So it's just taking the value that I have right now and then ORing it with the rest of the expression. This is similar to plus equals and minus equals as an operator. This is going to spin through my list of Pokemon, and then every one it inspects, it's going to give me that Boolean expression. Is it equal or not? If one of them is equal, then by the time we leave this loop, duplicate will be true. If none of them are equal, then duplicate will just stay false, because it's always going to be false or false, false or false. And then if it is actually equal to another one, it will be false or true. And then it's true or whatever, and true or whatever is always true. So we keep that nice structure. You can write this with an if statement. So you could say something like to add get nickname equals equals, I'm not going to finish the statement, then you could say duplicate is equal to true. It's the same thing. It's the same thing. We're accomplishing the same thing here. I'm just doing this in one line and with no conditional statements. If there is a duplicate, I don't want to add a new Pokemon. So I want to say if not duplicate and this cur Pokemon is less than 6, we don't have too many Pokemon, then add it to my roster. I also want to be able to say now, have you added this Pokemon or not? The way that I'm going to say that is I'm going to use another Boolean. I'm going to say that by default, I have not added a Pokemon. And then I'm just going to add a statement here to assign the literal true. We added it, so it's good. And then I'll return added. The big thing that we're getting here is that we can compare strings with equals equals. Unlike Java, we can make comparisons between strings with equals equals. We can also compare strings with not equals. So we can use like the basic operators on these string classes to make comparisons between them, and it will actually compare them character by character to see if they're the same thing. Okay. So we've added this functionality. I want to make sure it works. Yeah. Which one, sorry? Less than or equal to. So yes, you can use less than or equal to on strings, and it will do something like compare to behavior in Java. I can make it still, but I actually want to see if this works. The way that I want to see if this works is I'm going to add a new file. I'm going to add a new main function that's going to be my testing interface. I'm going to create a new file, and I'm going to call this one test trainer.cpp. This is just going to be a new file that has a new main function in it, and I want to use some properties. I want to test the implementation that I have here to make sure that it works correctly. So I'm going to include IOStream. I want to print stuff out. I'm going to include Pokemon.h. I'm going to include trainer.h. And I'm going to include PokePrinter.h. I want to try doing a couple things here. I want to try using stack and heap variables in this context. This is going to be a vehicle for me to do this. I'm going to create the variables that I'm going to be using for testing, the objects that I'm going to be using for testing as stack and heap variables here. So what I need for this test is I need to have a trainer. I need to have 2 Pokemon, or 3 Pokemon maybe, 2 that have the same nickname and 1 that doesn't have the same nickname to verify that this actually works. So I'm going to make a new trainer, and I'm going to call it just trainer. In this case, I didn't put an asterisk. I'm not making a pointer to trainer. I am just making an instance of this object trainer. This is a stack allocated instance of the trainer class. We don't need to delete a stack allocated instance of a class. We don't have to release that resource because we haven't actually acquired a resource in that same way that we are with new when we're calling new to get an instance of something. This is calling the null array constructor. This is calling that default constructor because I haven't put any parenthesis after it. If I say trainer, I'm going to say trainer Ash. I can also create a stack allocated instance of this class this way, and that's calling the other constructor that we defined for this class. So I don't use that keyword new anywhere to do anything with this. I'm going to create a couple of Pokemon. So I'm going to create Pokemon that are both ones that's stack allocated and one that's heap allocated, just so we can kind of see the differences between the two of them and how we're using them. I'm going to create this new Pokemon called Pika. I'm going to pop over to Pokemon.cpp so I remember the order of the arguments that I put into my constructor. So the first one is the type. So it's a Pikachu. Whoops, I don't want to paste that, no. The nickname is Pika, and its max hit points is, let's say, 30 to begin with. So Pika here is also a stack allocated object. This is a heap allocated object. And what I'm going to do is just pass in the same things. This is the thing I'm going to use for testing to see if it works. Okay. And the behavior that I'm trying to test here is if I add Pokemon that have the same nickname, it should be rejected. That's my goal. So I'm going to say this. I'm going to create this added variable here. I'm going to say ash.add. I have to give these different names. I have to give these different names. Two. Ash.add Pokemon. In this case, we use that dot notation. So we're using dot to call methods on this class now. With pointers, we're using arrows. With stack allocated objects, we're using dot. Add Pokemon here takes a pointer to a Pokemon. So let me go back to trainer.cpp. Add Pokemon takes a pointer to a Pokemon, and it returns that Boolean value. I'm going to add my first Pika here. So I'm going to say added is equal to ash.add Pokemon. And because this is taking a pointer to a Pokemon, I have to pass an address of a Pokemon object. So I'm going to use this ampersand symbol for Pika. Pika is a stack allocated object. So for me to pass a pointer to that thing, I have to pass the address of that thing. I'm going to say here, if added, added my first Pokemon. I'm going to actually write fail here. Okay. So there's my first little test case. Was I able to add one Pokemon to this trainer? Was I able to add one Pokemon to his roster? I'm going to do the same thing now. Added is equal to ash.add Pokemon. And this time I'm going to pass Pikachu. I'm not using ampersand because I've got a pointer to it in the first place. So I don't have to get the address of it. I'm just passing the pointer itself. And in this case, I should be failing. Okay, that's my little test suite here. I've stack allocated a couple of trainers. I've called the null array constructor. I've called the one with one argument. Our syntax here is that we just put our parenthesis immediately after the name. I've created a stack allocated Pokemon and a heap allocated Pokemon. And then I've tried to add. I use the dot syntax because I'm using stack allocated objects. I need to pass a pointer to a stack allocated object. So I use my ampersand. And in this case, I'm passing a pointer directly because I did a heap allocation for that one. So I just pass it directly. Now I need to update my make file. I also want to make test trainer. So I'm going to add that to my all target. And test trainer has a dependency on trainer.o, pokemon.o. It doesn't actually have a dependency on pokeprinter.o because I never used that class. So I'm actually going to delete this include. It's not required. Oh. Okay. Oh my God, sweet relief, it worked. How are we all doing today? Okay. Good. I went to the Leaf last night. I went to the restaurant there. It's good. It's really, really good. It's amazing. It was so expensive, but it's really, really good. If you have the chance to splurge, do it. It's also just a beautiful place to walk around. It's really nice. It was cooler in there than I thought it was going to be, though. Like, I kind of imagined like Tropical House. Have we all been to the zoo? Has everybody here been to the zoo? Has anybody not been to the zoo? It's okay. It's okay. Please go to the zoo. And I'm telling you this, like, you are adults and you need to go to the zoo. You have to go check out the polar bears. That's something that you are not going to see anywhere else in the world, unless you're going up to Churchill or something. There's a tropical house at the zoo that's just filled with birds and like jungle plants. And it is hot and humid in that building. It is a nice place to go on a cold winter day. But the Leaf was not warm like that. I expected it to be like that and it wasn't. So that's your homework for the weekend. Go to the Leaf. Yeah, go to the Leaf. Go check out the zoo. Go snuggle up to a polar bear. All right, so let's test trainer here. Let's run it. And what I am expecting to have happen is that I get 2 passes here. So I'm going to run that, and I get 2 passes. So great, that's really excellent. I'm so happy that it worked. I'm so happy that it worked. I'm happy with this. There's one minor change that I want to make to our trainer CPP class. And the one minor change that I want to make to this is that I don't really feel great that we're using this hard-coded 6 in here. I don't feel great with that. And what I'd like to do is make a change to using a class variable, so a constant class variable. Before I move on to that, just confirming we're okay. We can keep going. Good, 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 good. Great, excellent. So I'm going to pop up to Pokemon.h here. Class variables are similar to Java. So in Java, to declare a class variable, we're using that either public or private, but then static and final to declare a class variable. Static is saying that it is a class variable. We can do the same thing in C++. Whoops, I'm in the wrong class here. I want to go to trainer. We can do the same thing at C++ or something very similar to that. The syntax changes slightly for use in C++. It's not a major difference, but it's a difference. We still use the keyword static. We're still using that keyword static. In C, that means once per file. This is file private. It's file scoped, and it's limited to just this file. In C++ and Java, it's kind of tied to the class. It's a thing that's once per class. The other keyword that we're using here is const. Const says this is a value that's never going to change. This has got the same meaning to final in Java. I want this to be an int, and I'm going to use the same naming convention that I use for class variables in Java, constants, and I'm going to just make everything uppercase with underscores in between the words. So I'm going to say max Pokemon. I'm going to set this equal to 6. So I'm just going to initialize it right in line here. This is going to be part of my class interface. Within this context, I should be able to just say max Pokemon. I'm going to verify that. Good, that's still good. It's just replacing max Pokemon with 6 here. I'd also like to use it in trainer CPP. But now we're kind of out of the scope of this class definition. So for me to use a class variables in C++, we use it sort of the same way that we do in Java. In Java, with a class variable, we say class name dot, and then that variable name. Here, we're going to say class name, so trainer, colon, so kind of same as the way that we're making methods for this class, and then the name of the thing that I want to use. So max Pokemon here. Whoops. Just going to pop that on another line, just so we can see it all. So the syntax here is just use class name, colon, and then the name of the variable that I've got. Compile this again. It's still good. The behavior shouldn't have changed. I'm going to run test trainer again. It's still good. Okay, great. We're good. We're golden here. I think I'm satisfied with this. We've done class variables. We've done comparing strings. I'd like to move on now to thinking about making a class hierarchy in C++. So I'm going to pop over here. And I got a question for you. Right now, we've got 4 separate classes: Pokemon, Trainer, PokePrinter, and then at the very end of last class, I added this new class to you that's called item. This is what our hierarchy looks like. There is no hierarchy. This is what our hierarchy looks like, but there's nothing there. It's just 4 separate classes. My question for you is, what class do we extend? We've got these 4 classes. Which one should we extend? Take the time to think about it. Obviously, I'm going to just tell you what I'm going to extend. But I want you to take the time to think about it. What is the logical thing here for using as a basis for extension with this example that we've got? Well, why, hey, he added the suspicious extra class at the end of last class. What? Yeah, what's the deal with that? Okay. All right. Okay. I'm pretty happy with this. These 2 classes, Pokemon and PokePrinter, they are together. There's like a one-to-one relationship with these classes. There's Pokemon and there's PokePrinter. If we were to extend Pokemon, we would also have to extend that class so that we can get specific details about the specific type that we're talking about. I'm going to say it's not Pokemon. I'm glad that most of you agree with me. Pokemon actually kind of makes sense, though. It does. And if you've played Pokemon, it maybe makes more sense than if you haven't played Pokemon. But part of the game is that you've got these Pokemon. So I've got Good here. And Good is a Bulbasaur. That's its base type. Eventually, after doing a bunch of battles with other Pokemon, so finding other trainers to battle or just battling Pokemon in the wild, eventually this Pokemon will evolve into Venusaur. Venusaur. No, oh no, it's Ivysaur. Yes, thank you. Thank you for shaking your head at me. It evolves into an Ivysaur. And an Ivysaur is another numbered Pokemon. It's a different Pokemon. Eventually, Ivysaur will evolve into Venusaur after a certain level, after it's gained some experience. This Pokemon here, Eevee, that adorable thing on the right, it looks like a little puppy with giant ears and a big fluffy tail. This Pokemon can evolve into 3 other Pokemon. It can evolve into Jolteon with the Lightning Stone. It can evolve into Vaporeon with the Water Stone, and it can evolve into Flareon with the Fire Stone. A long time ago, like class 1 or 2, I forget which one of those things, which one of those 2 classes it was, I said something like this. Class hierarchies are like this genetic relationship between classes. You can inherit things from these other classes. Bulbasaur, Ivysaur, and Venusaur, they're all different Pokemon. They're genetically related to each other in that they evolve. They have some kind of relationship, but it's not obvious what it is. These 3 have the similar kind of genetic relationship. They evolve from one other Pokemon. Even if these evolve from each other, they're all still different types of the same thing. They're all still just Pokemon. They all still have the same kind of stats. So here we've got attack, defense, speed, and special. It's got type 1 and type 2. It has an ID number and an original trainer. It has some attacks that it can do. If I go to a completely different Pokemon, it's all the same stuff. It has some stats: attack, defense, speed, special. It has type, it has an original trainer, it has some attacks that it can do. There's no extension here. There isn't even really a clear relationship other than they are the same thing. They're just different kinds of the same thing. Items, which I think are the right choice for doing extension here, do have different behavior. I've walked us over to a store at the beginning of class, a Pokemart. Get out of my way. At a Pokemart, we can buy items from the counter. The items that we can buy are things like a Pokeball, a potion, an antidote, a burn heal, awakening, paralyze heal. At different Pokemon marts, different Pokemarts, we can buy different items. We can buy things that will give you more healing power. They'll change different properties of Pokemon. Almost all of these apply to a Pokemon in some way. They change something about a Pokemon. They have a common behavior. A potion takes as input a Pokemon that you want to apply it to, and it changes its current HP. An antidote takes as input a Pokemon, and it changes whether or not it's poisoned. A burn heal takes as input a Pokemon, and it changes whether or not this Pokemon is burned right now. An awakening takes as input a Pokemon, and it changes whether or not the Pokemon is sleeping right now. A paralyzed heal takes as input a Pokemon, and it changes whether or not the Pokemon is paralyzed right now. These are all different types of items. They're all different subclasses of items to me. They're all different subclasses of items that take as input a Pokemon and make change, some kind of specific change to a Pokemon. When I'm thinking about items, I want to basically be able to say, I have an item and I want to apply it to my Pokemon. I don't really care what kind it is right now. When I'm making instances of these classes, I'm going to be using that specific type, but I really just want to be able to call apply on a superclass. That's what I want to be able to do. So my goal here is to take this item class, and I want to be able to do something like this. I want to have a class item that has one single method that has a void return type. I'm going to call it apply. It will take as input a Pokemon pointer, a pointer to a Pokemon. And that's it. That's all I want this class to do. I don't want it to have any properties. I just want it to be a superclass. I know it's hard to see here, but I just put a little asterisk after that method. I'll delete it. I'll add it back. I'll delete it. I'll add it back. I'll delete it. I'll add it back. It makes this italicized. It kind of slants the text over a little bit. That's saying that I want this to be an abstract method. I don't want this to be implemented in the superclass. There is no default behavior for an item. There's no default behavior for an item, so I want all subclasses of item to implement this. I want them all to be forced to implement this. And I want to have, I'm going to start with one item, and my one item here is going to be of type potion. Potion is going to implement that method. But I'm not going to put that asterisk after it because it's actually going to be the implementation of it. The theory of this, if I were to keep growing it, is that I'd also want to be able to say that item is extended by paralyze heal, and item is extended by awakening, something like that. I want to have all of these different types of things be able to apply to a specific Pokemon. How they change the Pokemon is kind of up to them. So what properties they actually make changes to is up to them to decide what they're going to do to the Pokemon. But that's the general structure that I want. My approach to this is going to be just to stick right now to item and potion. So that's the only part of this hierarchy that I want to build today. But the rest is left as an exercise for the reader if you want to try doing something like this. So let's go back to our code. I'm going to close most of this right now. I'm going to make a new file that's called item.h. This is the new file that I'm creating. It's a header file, so I'm going to put pragma once at it. I'm going to include Pokemon.h. I need to know about that type. I could forward declare Pokemon. I will do that instead. I'm going to forward declare that Pokemon type. There is a Pokemon type. It will be there in the future when you get compiled, I promise. I'm going to say class item. Semicolon, There's only one public method on this. It's called apply. It takes a pointer to a Pokemon. When this header file is compiled, I don't need to know what the Pokemon class looks like. I just need to know that there is a pointer to Pokemon. So I don't need to include, that's why I'm not including Pokemon.h here and doing forward declaration instead. I'm going to add one more class here. And that class, that file is going to be potion.h. Now pop this over to the side. Pragma once. I'm going to include item. I'm going to extend this thing, so I do have to know what it looks like. My class type is potion. Can you hear me now? Yeah, so I can see here, it's just taking up the mic. So the audio is going to be terrible, I'm sorry, but it'll be there. Thank you for letting me know. So the override keyword here says, I want to override the behavior that's defined in the superclass. So item here has a virtual method, but there is still expected to be an implementation of that method. I'm going to make one final change here. I'm going to put equals 0. 100%. This is stupid syntax. This is the dumbest idea that I've ever seen in my life in programming languages. Equals 0 says that this is a pure virtual method. Pure virtual method is abstract. There is no implementation of that method in this class. The presence of a pure virtual method in a class in C++ makes the whole class abstract. So now item is not able to be created by calling a constructor by itself anymore. We can't do that anymore. It's an abstract class. We don't mark it abstract in the class definition. The mere presence of a pure virtual method says this is an abstract class. Yes?
So we can't mark it abstract? Or is this the only way to...
This is the only way to do it. There is no abstract keyword in C++. The presence of a pure virtual method makes the enclosing class abstract. Again, I did not come up with this idea. It's just what it is. Yeah. There has to be one or more. So the presence of any pure virtual method marks it as abstract. If you have a class that you want to be abstract that has no methods, so you don't want there to be methods, you have to have a pure virtual private method that's just like a dummy thing to say this is an abstract class. Yeah?
What would an impure virtual method be?
I don't know if you can put anything other than 0 here. I don't know. I have to be honest with you. I don't know if you can put anything other than 0. Have you tried? I don't know if you can. All I know is that for a pure virtual method, it has to be equal 0. I can't believe it that this is the syntax for this. I really can't believe it. I don't like it.
Can you make it equal anything else?
That was the question. So I'm going to put one here. I'd compile it, but nothing's really going to happen because I don't have implementations of these classes yet. So what I want to do in the last few minutes here is I'm going to change this back to 0, just so that we're like in the syntactically valid state. I'm not tripping myself up. I'm going to make a new file here that's called potion.cpp. It's going to include potion.h. It's going to implement this void apply. And I am going to want to call methods on Pokemon, so I need to also include Pokemon.h. I can't forward declare this explicitly because I want to call methods on this type now. So I have to include the entire implementation of that thing. My goal here is effectively to say, I want to say to heal, and then I will have to add a new method to my Pokemon class to increase HP by something. So that's what a potion is doing here. To heal, increase HP. And a basic potion, I'm going to say that it increases HP by 5. There are several different kinds of potions. There's super potions, and I think that's it. Are there more potions than super potions? Hyper potion, thank you. hyperpotions that we'll say are increasing by more. To use this, I'm going to pop over to my main. And what I'm going to say is I'm going to make sure that this compiles and put it up on the course webpage. It's going to be tomorrow because I have to leave like right after class today. But now that we've marked that method as pure virtual, and even before when we just marked it as virtual, this should work. This should now call the correct thing on the potion class. So the actual method on the potion class. There are some things that you still have to think about here. Just to sum it up. When a class is abstract, we can't do this anymore. We can't have a stack allocated abstract object. We can't do that because it's trying to call a constructor that doesn't exist. We're not allowed to create instances of this object anymore. We can do things like stack allocated potion type. We can do this, but we can't do stack allocated instances of abstract classes in the same way that we couldn't call new on an abstract class in Java. Okay, so I'm going to make sure this compiles. I'm going to put this up on the course webpage tomorrow. Quick summary. At this point, you should be able to write a simple C++ program with classes. We've gone through a pretty comprehensive example here that covers a lot of different parts of classes and other things in C++. You should also now be able to create and use a simple class hierarchy in C++. So we've got this item class. We have subtypes for the item class. You should be able to do this in C++ now. This part we were not able to do, and this part will not be on the term test. It will be on the next term test, but it won't be on this term test. But you should be able to describe and use the differences between stack and heap declarations for variables. So not describing an address space layout, but at least being able to describe the differences and using stack versus heap allocated. So dot versus arrow syntax to call methods on things. That's it for today. Thank you all for coming. I hope you have a great weekend. Please go to the zoo if you haven't been. Go to the Leaf if you haven't been. And I'll see you next week. Bye, everyone. Sorry on the stream if you were watching and you couldn't hear me, but yeah, I hope you have a good weekend, and I'll make sure that my mics are